Designing object-oriented software is hard. Designing reusable, maintainable, and readable object-oriented software is even harder. You have to be able to find good candidates for your system's classes. You have to be able to define inheritance hierarchies. You have to be able to define key relationships between classes. And you have to do all of this while making the code reusable and adaptable. Experienced object-oriented developers build up knowledge of general principles that guide them in the creation of software. Now, novelists, for example, they rarely design their plots from scratch. They follow patterns like tragically flawed hero. So Macbeth or Hamlet would be examples there. Romantic novel, murder mystery. Okay, these broad classifications make it easier to come up with plots for authors. Sometimes being constrained like this really frees you to be very creative. And we'll see this is true with software as well. A design pattern is a named problem-solution pair that could be applied in new contexts with advice on how to apply it. So in terms of a novel, we all know what happens in a murder mystery. Someone's murdered, we encounter suspects who may have done it, and then someone discovers who the real perpetrator is. The problem is determining who the suspects are, and the solution is finding the correct one. So a design pattern just describes the solution to a common problem. Each pattern describes a problem that occurs over and over again, then describes a solution in such a way that the solution can be used repeatedly without ever doing the exact same thing twice. So while programming, we encounter the same types of problems over and over again. But these problems are never identical to what we've done in the past. So we might be writing a spreadsheet program, for example, and realize that when a cell changes, several other cells need to be notified and updated. Okay, there's a good way to solve this problem. Later on, though, we might be writing another program that has to do with, let's say, social networking, where when someone updates their status, all of their friends need to be updated. This is essentially the same problem, and the same solution might be used in both, but it's not likely that you're going to reuse any actual code because the problem domains are so different that that will prevent actual code reuse. But the solution to the problem, that can be reused. So the same types of problems, like the one I just described of notifying other objects when one changes, these show up over and over again. This is why experienced programmers are generally better than less experienced programmers. More experience doesn't mean smarter. It means they've had more opportunities to solve problems and remember them, so that when they pop up again, they remember the solution. And believe me, often it's when you encounter a new problem, you try, and then you fail, and then you fix your solution. And sometimes it takes several iterations of that. But by the end, you have the right solution, and you have that in the back of your head. The solution to the problem will be written down and described in these things called patterns. And programmers could use these patterns over and over again in many different programs without actually sharing any code. So the idea behind a pattern is simple. You write down and catalog common interactions between objects that programmers have found useful over time. Right, so we'll see this pattern pretty soon. Okay, so we say, oh, this is actually the solution to that problem I talked about of notifying when one object changes. Okay, well there's a agreed upon solution that's the best way to solve this particular problem, and it's written down in a pattern called the observer pattern. Okay, another way to think about it is, well, let's say cabinet makers. And when cabinet makers talk to each other, they might say something like, well, this cabinet design is like that one, except this one has drawers instead of doors. Okay, so there's some context there. So this one is like that one, and then they identify the differences, right? So that's a very powerful type of communication when people have the same basic knowledge, right? So each design pattern systematically names, explains, and evaluates an important recurring design in an object-oriented system. Patterns come from the world of architecture, So there's a pattern to build an arch. No one has to figure out how to do this anymore. Nobody has to do the math to figure this out, because 2,000 years ago, some architect figured it out and wrote it down somewhere. So if you want to build an arch, you simply look up the relevant details in an architecture pattern book. Okay. So in general, a pattern has 4 essential elements. Every pattern has a name, and this is a short phrase that becomes part of our vocabulary to increase communication between team members. So it's not uncommon to say things like, oh, that sounds like an observer, or that sounds like a singleton to me, where observer and singleton are the names of patterns. Every pattern describes a problem. So it describes when to apply the pattern, explains the problem and the important context information. So for example, this is a solution to a problem, but it only affects multi-core architectures or something like that. Every pattern has a solution. This describes the elements that make up the design, their relationships, and their collaborations. The solution does not describe a particular concrete design or implementation. If it did, we would just be talking about code reuse, but that's not what we're talking about here. The solution provides an abstract description of the design problem and a very general solution. It's up to the programmer to take that general solution and apply it to their particular problem. Next, a pattern always has consequences that describes the results and trade-offs of applying the pattern. Okay, so the point of patterns is not to express new software engineering principles. It's actually exactly the opposite. Patterns attempt to document existing knowledge that has been verified over and over again by many software developers. The more widely used, the better, in fact. So if you think you've come up with a good solution to a problem, you can write it down, but it's not really a pattern until many people agree with you that that is the best solution. So you might one day, for example, write a paper that describes a pattern candidate. Okay, this is something that you suspect is the best way to do something, but it doesn't become a pattern until several people agree that yes, this is the best solution to the problem. Okay, having these patterns available to us makes software easier to write, easier to read, easier to extend and maintain. Now, a key aspect of learning and using patterns is understanding anti-patterns. When writing software, of course, there's always 100 different ways to do basically the same thing. A pattern documents the best way, and the other 99 ways are called anti-patterns. These are designs that may work but are flawed in some way, like they might be a little less efficient or a little bit harder to extend or a little bit harder to maintain. Okay, design patterns are descriptions of communicating objects that are customized to solve a general design problem in a particular context. And there are 3 broad categories of patterns. We have the creational patterns. These patterns describe how to create objects or groups of objects. So we'll talk about the singleton pattern, the factory pattern. Those are creational patterns. Then we have structural patterns. These help you compose objects into larger groups. So some examples would be the composite pattern, the strategy pattern, the visitor pattern. And then we have behavioral patterns. These help you define communication between objects in your system and how the flow is controlled. So we'll talk about observer, proxy, decorator, state. These are all behavioral patterns.